Hey there, my name is Alejandro and welcome back for day 37 of me doing the Daily LeetCode challenge until I reach 1 year's worth of green contributions here on GitHub. So today's problem is for August 22nd, 2024, and let's get straight into it. Okay, today we get a LeetCode easy. Problem 476, number complement. The complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to zero in its binary representation. Okay. For example, the integer 5 is 101 in binary, and its complement is 010. So it's not 2's complement, where you also... Okay, it's just literally complement. Okay, give it an integer num, and it return its complement? Bro, there's no way right now. Okay, well, okay. Oh, you get the number as in non-binary. Oh, okay. So you take the number, convert it to binary, do the complement, then get okay, that's fine, and so on. I wonder if there's like libraries like I know in Python you have stuff like this. So I think it's like bin. So if I do like bin 41, okay, you get the binary of 41. Then how is it? Can I do int of bin of 41? Does that work? No. Maybe it's like base 2. Yeah, there we go. Okay, so this will be a very, very easy problem, right? Where it's like, let's take a number 5, right? So we can take something like num equals 5. Then we say bin of 5, yeah. So we want to skip the 0b at the beginning. So we do that. Then dot map. Actually, how does map work in Python? So map lambda I times 2, comma 1, 2, 3. What does this give me? If I do list. Okay, so one thing that's cool about ones and zeros is like if you do 1 minus x, where x is either 0 or 1, if you get 1 minus 0, it becomes 1. And if you have 1 minus 1, it becomes 0. So it's actually a function that will turn 0 into 1 and 1 into 0. So we can do something like, okay, map lambda c map. Okay, so basically we're gonna have, okay, you know what? We can come up with a one-line solution, right? I can first of all do it line by line so that it's very simple. So convert num to binary, e.g. 5 into 0b 101. Num binary num is equal to bin num. Ignore first two characters, e.g. 0b 101 goes into 101. So we'll say bin num equals bin num from 2 and onwards. Flip all the digits, e.g. 101 becomes 010, right? And if I do int of 010, comma 2 here, that does give me 2. If I did 0b, yeah, it's the same thing. Okay. So I can even skip this. Obviously I can't do it for every character. Yeah, lol. Flip all the digits, so bin num equals, so for I in range length bin num of I equals, let's say 0 if bin num I equals 1, else 1. Or we can make it cooler by bin num of I is equal to, actually, okay, so we'll keep it like this. So let's solve the problem first, right? We're gonna do line by line, but otherwise we can do some cool, sexy one-line Python solution, right? So that's what I want to do. But otherwise, this is so that you guys can understand how I'm gonna do this problem. So flip all the digits, e.g., 101 goes into 010, and then convert num binary into decimal, e.g., 010 into 2. And so one way you could do this is like, okay. So this is a shortcut. If I do int of binary num, comma 2. So if I return this, I think our solution works, right? Bruh. Oh, I see. Flipped bin num equals string.join string of 1 minus int of digit for digit and bin num. So we'll do that. Flipped bin num. And there we go, right? So that's essentially the solution. So we can remove something like this. And okay, so what I was going to say is that basically you can do this. So you can multiply this number by 2 times 2 to the power of 0, this number by 2 to the power of 1, this number by 2 to the power of 2, so 0 times 2 to the power of 1. So this will be 0, this will be 0, but 1 times 2 to the power of 1 will be 2, and that's how you get to it. So you could do the calculation this way. This is just a Python way of doing it fast. So if we submit a solution like this works, right? Bada bing, bada boom, okay, and we're actually like 5% slower, unless it's like because it's just like tiny bits of milliseconds and so on and blah, 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 right? Or also because we're doing this thing, right? So yeah, here's 61%. So okay, this problem is insanely trivial and at least a nice break from yesterday. Otherwise, we can try to do this in one line, right? So let's return. What are we gonna return? So we want bin of num. So now we have the number in binary like 0b101. And then we're going to do, so okay, we want to ignore the first 2 characters. Then we're going to do string.join. So we're literally going to do this, actually. Instead of bin num, we're going to have and this is going to be bin of num. We're going to call this D. A 4-digit, yeah. And then we're going to say int of this base 2. And now if we remove everything else, we submit this. Oh yeah! Oh, that's funny. Is there a better way to do this? Actually, we could do if d equals 1, else 1. So we could do something like that. Maybe that's even faster. Let's submit it a couple times instead of like string and int conversions all the time, right? Actually, that makes it slower. Okay, so this is faster. Okay. There we go. This is our solution. One line, 78%. Very nice. Okay. Otherwise, we can explain kind of how I did this. So, yeah, I'll revert to this. So essentially, like, this is exactly how I'm doing it, like step by step, right? So this is quote unquote the shortcut way, where I'm doing like all of this in one line essentially. But otherwise, like, so usually I do a summary of my video. Here I wrote the code kind of in a self-explanatory way. So what this problem is asking is literally take a number and find its complement. And the complement is defined by taking the number, converting it to binary, flipping the ones and zeros around, and then reconverting that number back to decimal, right? So this is exactly what we do. So we convert the number into binary. In Python, you have a bin function. Otherwise, the way you would do it is like you would subtract 2 to the 0 from 5, so 1, and so, or actually, okay. Or, well, okay, you could do some funny stuff in order to convert the number into binary. So it's like, yeah, you modulo every time and so on, blah, blah, blah. You could just combine it. In Python, conveniently, there's just a bin function, so you can convert any number into binary, so it's very useful. And it gives it to you in this string with 0b and onwards. So what I do is, like, first I'm like, okay, let's just get rid of the 0b. That's not what we want. This is the actual binary number. So from index 2 and onwards, that just means like, okay, we get 101. And so here I was just putting it as a string, even though we don't need to. In fact, if I remove it, I'm pretty sure like this still runs. Yeah, there you go. Okay, so I'm literally just getting rid of the first 2 characters. Then when I have something like 101, I want to flip every digit from like 0, 1, 0. I could literally just say like, okay, for every digit, just do 0 if the digit is equal to 1, else 1, you know, and so flip it that way. All I'm doing here is essentially like, if you have a function like f of x is equal to 1 minus x, then one thing you realize is that if you have f of 0, what is this equal? 1 minus 0 is equal to 1. And if you have f of 1, this is equal to 1 minus 1 is equal to 0. So you can see that on input 0, the output is 1, and on input 1, the output is 0. So it's the same thing as flipping 0 to 1 and 1 to 0, right? So that's essentially what I did. It's like a little trick that I learned in my discrete math class in first year of university that ended up being like very, very useful for a lot of proofs. So that's it. So yeah, so that essentially what I'm doing is like for every digit in binary num, right, where it's like some string like 101 here, right, all I'm doing is like, okay, if I see a 1, I make it a 0 now. If I see a 0, I make it a 1, right? So that's literally all I'm doing. 1 minus the integer digit of whatever I'm doing for every digit in binary num, and again, 1 minus 0 becomes 1, so 0 gets mapped to 1, and then vice versa, so 0 to 1 and 1 to 0, right? And so again, I just do string.join, so it's basically like just join all those characters together. So I populate this 0, 1, 0 here, and then from 0, 1, 0, we will convert from binary back to decimal. So one way you can do that in Python is just by doing int with the binary number and specifying a base of 2, right? So you have the number in base 2, and then it'll just give you the actual integer. Otherwise, something you could do is like, let's say we do this. Power is equal to 0. We'll do for digit in flipped bin num, and let's go backwards, right? So we'll say result is equal to 0. For digit in digit flip bin num backwards, we're gonna say result plus or equal int digit times 2 to the power. So in Python you can actually do pow 2 to the power of power, right? And so here every time we're going to update power by plus or equal 1, right? And then if we just return res here right before we even return this thing and we run it, this should be correct. Right, so yeah, so the idea is like here I'd say, okay, 0 times 2 to the 0 is what? 0. Okay, 1 times 2 to the 1 is what? 1 times 2 to the 1 is 1 times 2 is 2, right? And then 0 times 2 to the 2 is 0, right? And so that gives you, and when you take the sum of all those things, it gives you 2. So that's one way you could do it. It's just that Python gives you a nice little neat way to do it with the int function. And again, that's what I meant by here. Like you can just do some like similar like kind of magic, quote unquote, to convert a decimal number to binary. It's not too hard logic wise. And essentially that's kind of it, right? And so it's again just these steps, just take the number, convert it to decimal, right? Just an extra step here because the bin function is a little annoying in Python, but otherwise you convert the decimal into the binary number, flip the binary number to get the complement, right? Then from the complement, convert it back into the number and then return it, right? And so that's essentially it. And otherwise, if I ignore these comments right here that I made, essentially all I did is I took all those ideas and pasted it into one line just for coolness sake, right? It looks cool whenever you have a one-line solution on GitHub. Although, okay, 24%, yeah. So the problem here is that the milliseconds is like very, very low. So like there's a huge amount of discrepancy. So there you go, like 87% and so on. So it is what it is. Otherwise, that is pretty much it for today's problem. In case you want to do something similar to what I do, the extension that I use is called LeetSync. So what these guys do is whenever you submit a problem like here I have done on LeetCode, it'll automatically push the solution that you wrote into your GitHub repository. I trust this extension, but by no means does this mean that you have to trust this extension yourself. But otherwise, this problem is called number complement. If I come here into my GitHub repository, you'll see that if I search up number complement, it'll say that I submitted a solution just now. And if I come in here, you'll see that I'll submit a copy of the README to the problem the very first time that you submit the problem successfully, as well as a copy of the solution that you just submitted on LeetCode. So here, maybe I can get rid of the last new line. That way, like my solution happens to be 3 lines long. So 87%. And here, if I come back into here, you'll see that, okay, maybe you give it some time for it to update. And there you go. So like 3 lines and so on. So whenever you change the submission, it'll just automatically change your GitHub. So very, very, very useful extension in case you want to do something similar to what I do. For me, the reason is simply because I want to get 1 year's worth of green contributions here on GitHub. But otherwise for you, like maybe it's like to serve you as an index of like a reference of solutions over the long term and so on. Or even if you lose your LeetCode account and so on, you have like your full collection of problems solved on your GitHub account. So for whatever reason you might want to do, even if you want to like start solving them in the same way that I do, whatever reason it may be, it's very, very useful extension in case you want to do something similar. So yeah, I figured that in every video I might as well plug it in case you want to do something like what I do. But otherwise, that's pretty much it for today's video. I really appreciate you for staying here and watching till the end. If you did find this useful or enjoyable, I would highly appreciate if you left a like or a comment. If you leave a comment, I promise that I will reply to you and every single person that leaves a comment on this video. I love hearing what you guys have to say. So if you have anything to say, whether it's feedback or the other way around or anything, or if you just want to have a chat or tell me about your LeetCode journey and want to motivate you to do LeetCode, I'm more than down to have a chat and conversation with each and every single one of you guys. I love talking to you guys whenever you talk to me. So whenever one of you comments, it always puts like a smile on my face, and I'm like so excited to reply and so on. So yeah, if you feel like saying something, feel more than welcome, and I would love to have a chat with you. Otherwise, again, that's pretty much for this video. It was a very simple one. We got a LeetCode easy, and it was surely a very good LeetCode easy in the sense that it was easy and nice. But yeah, otherwise that's pretty much it. I think I said that like 10 times, but but otherwise that is for the last time pretty much it, and I'll just catch you in the next one otherwise. So until then, ciao ciao my friend, and have a good rest of your day. Bye bye.